Greetings, everyone. This is the Prive working group session for IETF 112. I believe we're sort of in Madrid, if I remember the schedule correctly. We're going to go ahead and get started. My name is Brian Haberman, and I'm joined by my illustrious co-chair, Tim Wasinski, and I believe sitting in the sitting in the audience somewhere is our fabulous area director, Eric, so he can always keep us in line. Quick couple of notes here. Jabber Room is pretty much where it's always been at dprive@ietf.jabber.org, and we'll be keeping minutes in the through the tools link that's provided on the page. Tim is going to try and keep notes as much as possible, but we do have the ability for anybody else to jump in and help if they feel the interest. To make sure that we're getting all the correct action items and important points down for posterity. Before we get started, a couple of administrivia slides. The first one is the note well. I think everybody who has been to an IETF meeting, you should be very aware of this and have read through these documents. They include a number of important pieces here, including the standards process, harassment procedures, anti-harassment procedures, copyright processes, code of conduct, and et cetera, et cetera. So if you have not read this recently, please go do so. And we just promised not to have a pop quiz at the end for these. Other piece of administrivia, we've been trying to push code of conduct guidelines that have been documented in RFC 7154. Quick set of introductory meta points for this. I don't think there's anything here that is of surprise. We're trying to be as inclusive as possible and basing everything based on our best engineering judgment. And as Tim indicated, these slides came from Wes Hardiker. So thanks to Wes for putting these together for this working group and other working groups that have probably pillaged this slide at some point in time this week. So our agenda, pretty much a standard flow for the Prive working group. Anybody who has updates they want to make to the agenda, we'll solicit those in a second. We'll go through some updates of existing current work. And then we'll talk about current working group business, and then we'll cover any new working group business that's been brought to Prive. If you really want to track what's going on, the data tracker link on the slides will get you right to the Prive space, show you all the documents and the progress of all those documents. So for the agenda, first couple of things we're going to talk about are going to be, some cleanup of some work that we're trying to advance into the ISG for publication. That's the DNS over Quick. It's been through working group last call, and right now we're having a side conversation about doing an early port allocation of port 853 for Quick. The issue we have here is that that port has already been reallocated for DNS over DTLS. Both the authors of the DNS over Quick and the workgroup chairs have been poking around, and we don't seem to be able to see any implementations of DNS over DTLS, and it is an experimental document. So one possibility here is to actually mark this document as historic and then reallocate that port for use for DNS over Quick. That would be an IESG action, but we would need to first discuss in the working group whether or not we want to move DNS over DTLS to historic. And I don't think we're going to try and discuss that here. We'll probably have this as a point of discussion on the mailing list, or if we have some time left at the end of the session, we could revisit this point if people want to have an in-person discussion. And then for the agenda, we'll have the authors of the unauth, the authoritative, give their presentation on what they've been doing. They do not have slides, and so they'll just be talking to points that they want to make. And then going forward, we're going to have a presentation from Joey Salazar on a new draft that they have not actually posted the IETF, but we have made the GitHub repo available for people to review. And then Ben is going to talk a little bit about his DS glue draft. And then we have a set of drafts that were just posted to the mailing list that will be presented by Brian Dixon. So at this point, I'd like to ask if there are any people who want to see a change to the agenda, either a reorganization, add, delete, what have you. All right, hearing nothing, then first on the agenda is, I assume it's going to be Paul to talk about the unauth to authoritative document.
Good morning, at least for those of you from the West Coast. So we have no slides, and we were allocated 30 minutes, but we're going to use way less than that, which is okay, because we would be, when I say we, I mean Peter and I, would be happy to have more time to talk about the next presentation from Joey and DKG. Basically, the status of the unauth to authoritative document is we posted the 04 draft about 6 weeks ago. We announced it on the mailing list. We asked for comments. There's still a few open issues, especially with respect to how this might interact with a fully authenticated system. And we got absolutely no replies. So not sure what that means for now. But it either could mean the document's perfectly stable, which seems unlikely, or that the working group is thinking about use cases again, which would actually be good. I'd like to see more thought put into use cases. If the working group is happy with the current draft, with unauth to authoritative 04, and the fact that it uses SVCB as the protocol for tracking, and we have just a vague mention of probing in there, maybe we want more, or maybe the working group wants more. If that's the case, then Peter and I have talked about starting some interop testing. The status currently is that it would be experimental, but if we do a bunch of interop testing and developers and operators are happy with it, then it could probably start off on standards track. On the other hand, the working group might want to go in a different direction with a different use case, such as the unilateral probing that we're about to hear about. And so, we wouldn't want to start doing interop testing and such if it looked like that the working group was in fact interested in a different use case and a different way to do things. So basically, we're waiting on working group input. And we've tried so far, and I think we've been successful at keep making changes in every draft for based on working group input. We started off with doing just probing, and the working group said, no, we can't be doing probing because that won't work in parallel with a fully authenticated use case. So we included a fully authenticated use case. We took that out when there was a draft that started to describe the fully authenticated use case. We took out probing, and we're using SVCB. So possibly the working group's just getting confused with all of our changes that we've been doing for the working group. But the status is we're waiting on working group input. And that input could either be, please make these changes in this draft, or we're looking for a new way of doing things, and such as the one that we're about to hear, which is just fine. Peter and I both, our desire here is not to have finished an RFC, but to get more encryption on the internet. And the best way to do that is to have a document that there are a lot of vendors and developers behind. that's our document, great. If it's a different document, great. I guess I'm pushing for a little bit more input regardless of what it is. And that's all we have until we hear more on the mailing list. There isn't much we can be doing. So um, back to you, Brian and Tim, or if people have questions on this, that's fine. But again, our strong preference is always to be getting discussion on the mailing list, especially on a document like this where there was strong interest in the use case, but also strong pushback against the use case. Mailing list traffic is really the most valuable here for documenting what the working group wants.
Thanks, Paul. Anybody have any comments or questions for Paul? Joey.
Thank you. I just wanted to say that first apologies at a personal level because I have been meaning to get um, some input for this draft in the mailing list. I will get to it, I promise. So in the meantime, I just wanted to say that at least from my perspective, and I believe that DKG shares it, and he will probably talk about this more when he presents, is that I don't think that is this should be a question of either or. I think that the use case that you guys are working currently on this draft, the unauthorized encryption is good, and like the development of this document shouldn't, or at least from my perspective, I wouldn't like it to be like trumped by the development of other use cases. I also think that more encryption in the net is the way to go. Like my perspective for about the draft that DKG is about to present is that we should simply talk about the different use case scenarios and work on them. Mm. And I think that as we move along, uh, or as we go down that route, we will simply get more clarity in either all of the use cases, or we will focus on one use case at a time. And then, yeah, that's just my perspective. And I just wanted to make it public. Thank you.
Great, thank you. And I do think that us rekindling the use case discussion on the mailing list without it being about a particular draft would be good. And I don't want to foreshadow the next document, but just to be clear, Peter and I feel like that their use case is just fine. So it's not a one use case is better than the other. It's just our draft has evolved in a certain way. Their draft is starting from a certain perspective, but again, we think that we've stated the use case for the current working group draft as clearly as we can. We're really happy that they stated their use case very clearly from the beginning. It's not just, hey, we have an idea of how to do something. So I would love to see more on that. Maybe the working group does want us to both go at the same time. We're happy to do that. But we need to hear from the working group.
Brian Dixon.
Obviously, I'm presenting later in the session. I think the only places there might be some concern I didn't fly yet on the mail list was because I've only just done the work on the authenticated to authoritative proposal. And it would be premature to comment until I actually have the drafts ready to compare, and that's really only just been done. Plus, getting feedback from the working group on what's in my drafts. The only place that I think there is concern, and I'll address that on the mailing list, is just the differences in signaling protocol-wise that are probably not compatible completely or duplicative, and it might be something where switching the signaling method from SBCB to what I'm proposing might be something to consider. What I'm doing, the intent is to make it very quick and easy to pass and adopt. So we'll see. We'll wait for feedback from the group. Thanks.
And again, yeah, thank you, Brian. But again, the working group has to decide whether a use case is that the unauthenticated use case needs to be aligned with the fully authenticated use case. We currently are doing that because the working group asked us to do that about 9 months ago. So the current draft has that alignment as part of its use case. But then the interest in the fully authenticated fell off, at least from the document authors. So the working group needs to decide whether that alignment is important or not. If it is, it changes a lot of things in the protocol. If it's not as important, then it frees things up. And again, we're going to see that in the next presentation.
I agree. Thanks.
Eric.
Hi, Paul. I wouldn't characterize the situation quite the way you just characterized it. I know you just characterized it several times.
I'm using the information in front of me. Please give me more.
Sure. I'm about to. I wouldn't say interest in the use case from the document authors. I would say interest has remained constant. I would say my estimation of how likely the working group is to be interested in doing this has fallen off. And so my interest in continuing to fight about it has also fallen off. So based on this discussion with based on how Ben's draft is received, my interest may revive. But as I said at the very beginning, I'm interested in doing something here, but I'm not interested in spending the next 5 years of my life arguing about it. And so to the extent to which the working group wants to do something, I'm prepared to do that work, but I'm not interested in spending a lot of time trying to sell the working group on it, which has been my position from the beginning. So, so now I think we're clear on the situation for the authors. Okay, thanks.
Yeah. And very fair point is that we had some good input on your draft, and then it fell off. And yes, there is the question of, and Peter and I are feeling this as well, of how much are we supposed to be selling? Is it worthwhile doing the selling? And I totally hear you on the not wanting to spend time on doing the selling. So great.
All right. So I guess the question I have
yeah. Sorry. Go ahead, Brian.
Oh, sure. Sorry, Paul. Yeah, I don't see anybody else in the queue. So I think there's a couple of different ways that I could see going here, and I'd like to get your opinion on them. One is to do a working group last call to make sure that people are at least happy with what's been specified in the document to date. But I think at that point it would be, essentially using a process from other working groups where if we're happy with the version that goes through that working group last call, we would just mark it as ready for experimentation. It wouldn't advance. We would just keep it in a steady state and mark it some way that it's the stable version for experimentation. The other option would be to hold off on doing that kind of working group last call and do more of that use case discussion that you've talked about. Do you have
Brian, and to be fair, that you talked about very early on. I mean,
yes.
We're following your lead on trying to do that.
Oh, no, right. I'm just saying what you mentioned today is where I was going, right? My concern there is that, we seem to have intermittent interest from other working group participants to do that. And so I'm just curious, do you have a preference for one of those two approaches as an immediate next step?
I'll speak for myself, and maybe Peter will get in the queue. I prefer the second one. I prefer that we don't say that this is finished for two reasons. One is it only vaguely hints at the use of DS glue. And we haven't gone far with DS glue and such like that, or some DS glue equivalent. Maybe some of the stuff that Brian's going to be presenting. So I don't feel that we are actually complete. I don't think that we are even complete with the stated use case. So I would prefer more use case discussion that Peter and I can track and stick into the document. And again, the document sort of waving around depending as the working group goes, but we're okay with doing that. I would prefer that than to have anyone see a stable document and feel that they were supposed to be implementing from it given that there are known holes. I don't want to say it's stable with holes. That feels weird to me. I don't want implementers spending their time on it.
Yeah, that's fair, and I appreciate that view of the state of affairs. Tim.
Hi, thanks, Brian. Thanks, Paul. Would it help us, and maybe we can get our AD to weigh in, if we had reviews from some of the other directorates on the document, like now, while we sort of go through the experimentation process, just to see if we're covering all our security bases or things of that nature, right? It's just more of an open-ended question, right? I don't know
my
the right answer there.
My personal feeling is no, because what you're asking is what is specified there correct and good enough? And like I said, it's got holes because the working group has had holes. So for the same reason, I don't want to have implementers spend time on something that might change. I don't want the directorates to feel like that this is something that they should be evaluating if we know it has holes, because the holes as they fill in will certainly add security properties. I mean, I don't want a sector review that says this obviously has holes for security properties, because we know that at the current time.
Okay, thanks, Paul. Yep, I get that.
Eric.
I mean, so I basically, Paul and I think differ about the best technical approach, but I agree with Paul on the procedural point. Like the underlying problem is that the working group has not come to consensus on what it wants, and so we have a bunch of proposals with sort of like various kind of like mad levels of support, and not much implementer action or I think progress towards consensus on the overall approach. And like, I think, we both in our own ways attempted to like whip some of that support and not really succeeded. And so I think, like, I think we understand pretty well what Paul's proposal, I think we understand like pretty well what it does and what security properties are. And I think like, like I think, that's much less clear with any of the authenticated proposals, obviously. But I think like, the question is, what is the work we want to move forward with as like the place where it wants to like focus its effort for the next year or so in terms of driving both specification and rollout. And I think until we decide that, like trying to run the IETF machinery of like, publishing specification will have the same sort of like, we'll be in a position in 5 years of being like, do we deprecate the port, that we tell us now, we deprecate the port that we assigned like false thing for like a new thing or the thing we propose. So I think that's not like the way to go. It's like, we gotta like get to a point of consensus. And I don't know, like, or I think declare failure, by the way, would be also an alternative. But I think like and I had a better proposal, I would, in terms of like how to get there. But I think like the chairs needed to craft some sort of way to like get us to that consensus, or to declare failure.
All right. Thanks, Eric. So what Tim and I are going to do is we're going to go off and probably huddle with the with Eric to discuss ways to try and get this discussion facilitated in a way that gets us to a point where we can actually determine whether or not there's consensus on any of this stuff. Because both Paul and Eric are right. We've been around on these for a bit over the last few years, and there are pockets of support for different approaches, and I don't think the working group has a clear consensus on any one or two things they want to work on. So we'll figure out a way to facilitate this discussion going forward. All right. Next on the agenda is DKG and Joey to talk about their new draft.
Thanks. So you're running the slides, Brian?
Yes.
Great. Thanks. So Joey and I wrote this draft. I would run video, but last time I tried that, my ancient laptop started crapping out on the audio, so I'll stick with audio for now. So I'm going to present this. This is joint work with Joey, and this is an unusual. Sorry that we haven't posted this directly to the data tracker. We sort of missed the cutoff, and then I guess we could have done it at the beginning of the week, but we'll do it shortly. we have a link to a GitLab repo people can follow here. Next slide, please. So the goal here is to talk about, this is an unusual draft because it's actually describing no protocol elements whatsoever. It's describing internal state and proposed guidance for implementers for how to unilaterally probe from the recursive resolver to an authoritative server. So the reason that we were interested in, like, what does this actually look like, is kind of because we wanted this opportunistic mechanism to get out of the way of something that gives you stronger guarantees. In particular, we want to say, like, imagine you were a DNS authoritative server. What should you do if you don't want to risk things getting locked down? If you don't want to risk, breaking your setup, what can you do that would be relatively safe to do without coordinating or signaling to anyone else that you're doing it? And likewise, for a recursive resolver, how could you probe as you're doing authoritative queries and end up encrypting the bulk of your traffic, even if it doesn't mean 100% protection and it doesn't mean protection against active attacks? How can we reduce the visibility to a passive monitor? And we want this proposal to really be out of the way and not interfere with or provide sort of conflicting guidance with a more robust approach along the lines of, like, fully authenticated, potentially with hard fail. And what's interesting is that if we do this, it actually gives us some insight into what we think the signaling should look like for the stronger connection, the stronger encrypted and authenticated connection between the recursor and the authoritative. So the line I wrote in here is, raise the floor without lowering the ceiling. What can we do to just get more of the traffic protected against a passive monitor without getting in the way of the stronger connections? Next slide, please. Okay, so if we start to do probing, what are the things that could go wrong? The draft tries to figure out what we can do to minimize certain bad things, right? So we don't want to see DNS queries suddenly become much slower. We don't want to see the recursive resolver consume, 1,000 times as many resources, or the authoritatives. We don't want to see them flooded with annoying overload. We certainly don't want to penalize resolvers, authoritative servers that adopt these things, and likewise, we don't want to. We wouldn't want a recursor that's doing this probing to degrade its service to in other cases, and we certainly don't. We also want to minimize the amount of data that we accidentally leak. I'm mindful here that StarTLS, when we introduced it to SMTP and IMAP, we didn't have a good roadmap out of that, and it's taken us many, many, many years, far too long, to go from StarTLS and those protocols to stricter transport. So we want to make sure that we don't, lock in a protection against passive attacks that's still vulnerable to active attackers. So those are the concerns when you're trying to think about how to do unilateral probing, at least the concerns that we came up with. Hopefully other folks in the working group, if they have other concerns, will raise them. Next slide, please. So let me just go into what the draft suggests as guidance for the different servers involved. We basically say, if you're an authoritative server, do what you can, and here's what you can do. Listen with DNS over TLS on port 853, or listen, and listen with DNS over QUIC on UDP port 853. We just recommend that you do those things. There's no reason not to do them. You don't need to worry about how you authenticate. You can just offer any old X509 certificate. And if someone comes to you asking for SNI, you don't really care, just respond. It doesn't matter what the SNI is. We looked at asking the authoritative servers to opportunistically offer DOE on port 443. But if we did that, we need to specify what the path part of the URL would be. And we didn't want to make up what a standard path would be for DOE. So we just kind of left it at DOT and DOQ. If folks, I think that what we specified in the rest of the draft will actually work fine if we throw DOH in there as well, if someone wants to choose an expected path, but we didn't feel comfortable doing that. So we left it at DOT and DOQ for now. Next slide, please. So the guidance for the recursors, for the recursive resolvers, is significantly more detailed than the guidance for authoritative resolvers, because The recursors are the ones that are where it's really on them to do the probing, right? The authoritatives just sort of have to offer it, and then the recursors can try. And so what we've done is we've outlined what we think is a reasonably complete specification for the type of internal state that's needed to probe for DOT and or DOQ based on the authoritative IP address. So note that this probing is done by IP address, not by NS name. It's also not done by the zone that you're looking up. The probing is entirely like, hey, when I connect to this IP address, can I make the connection work? And that ends up playing a role in how this interacts with the authoritative servers. Whatever the stronger proposal ends up being. I want to note a similarity here that this has to the happy eyeballs guidance. So this is not novel. The IETF it's not like recommending implementation guidance without specific protocol changes is a totally novel thing. The IETF has recommended some happy eyeballs work for IPv4 and IPv6. Obviously, this is not exactly the same as happy eyeballs for IPv4 and IPv6, but it's a similar type of guidance. It says, hey, try these different channels at once. If you get one that works, here's how you should prioritize the one that's working. So we map out like a specific set of internal state. It's relatively minimal. We don't think it's a big burden to implement, and it outlines how to update that state depending on what you encounter on the network. Next slide, please. So we have a set of parameters. These are probably supposed to be, the easiest thing would be to make these global parameters for your recursive resolver. You could, again, this is unilateral, so you're not negotiating this or publishing it anywhere. These are just parameters that you might need to write down someplace. And maybe you want to offer them as configuration parameters tunable by the administrator. Maybe you want to have distinct parameters depending on the zone, the IP address, or the name server that you're looking up. You could do those things. I think the simplest approach, and the goal here is to provide a simple recommendation, is you just have this as a global parameters for the recursive resolvers, right? So we want to know how long do you remember that you had success at making an encrypted connection? We call that persistence. We want to know how long you avoid retrying encrypted transports once you found that none of them work, and we call that damping. And then we want to know, if you're trying encrypted transports because you knew that they were good, and then they start to fail, we want to know how rapidly you fall back to clear text transport. And so we call that timeout. So those are the three different parameters that we think you need as a baseline to make this algorithm work. Next slide. So I'm not getting into the exact steps. The draft actually outlines fairly detailed, like what do you do when a connection fails? What do you do when you run out of resources? How should you try them in a happy eyeball sense? You open the connections all at once. You see what one comes through. The clear text will probably give you a response first, but leave the attempts at encrypted transport open to make sure that you have the connection. It gives you guidance on sort of all of those steps. I'm not going to go into detail on what that guidance is. I hope people will read the draft and correct the things that Joey and I have missed, or places where we might have gotten it wrong. The implementers, people who have existing recursive resolvers could look at that and tell me probably, no, you forgot this particular failure state. We'd love to get that kind of feedback. But one of the things that outlining this does is it sort of gives us a clear sense of, if you wanted to signal, which this draft does not do, what would you need from the signal to do better than this draft? In particular, so we were looking at the stuff that Paul Hoffman wrote, and we looked at it, and I think we were saying basically, once we're doing this kind of signaling, we think you can do better than unilateral probing. And the things you need to do better are not signaling, hey, this thing is available, because the way that you signal, hey, this thing is available, is you just make it available, right? It's just as easy for me to make one query to the authoritative server on port 853, or two, one on TCP and one on UDP, and get an answer, is this thing available? What we really need from the signal is an indicator by the zone operator that says, we do expect encrypted transport to be running, and we expect you to be able to authenticate to it. here's how we expect you to authenticate it, and here's the thing that you need to authenticate. Now, we might decide that you don't need to explicitly mark this in the signal, because we might decide, for example, it's only going to work with X509. It's only going to work with the NS name rather than the zone name or something like that. Whatever we define for how the signal should work needs to answer these questions. But this is information that we need. We need one more slide full of information that I think we need from a signal. Next slide, please. Okay, and so most critically here, we need to know whether the zone operator or the name server operator, depending on where the signal gets placed, whether a hard fail should be in place by the recursor. Now, of course, we can signal we'd like you to hard fail if you connect and if you try to connect and authenticated strong encryption is not available. And existing resolvers simply won't hard fail, and that's understood, right? But we can signal that we want a hard fail in the same way that like MTA STS or HSTS says, don't bother connecting in the clear text. I've committed to this authoritative resolver being strong. This is about like, let's think about this from the outset here, so that we don't get into another start TLS situation where we have a decade go by before somebody says, let's avoid the active attacks. And then additionally, we probably also want a signal that says, if secure transport fails, let us know. Now, note that that's distinct from hard fail. You might want to initially say, don't hard fail as an authoritative, and just collect reports from people that says, you know, hey, I tried to do an encrypted connection that was authenticated and I didn't get it. So it looks a lot like TLS RPT. Ben, I see you in the queue. I'm happy to hear your feedback.
All right, no, I'll wait.
Okay. Next slide, please. So if we think that a signal could have the types of details that we just outlined in those two past slides, the next question for unilateral probing is, how is this going to interact how is this going to interact with the strong crypto? So the signal that we get for strong crypto is likely to be bound either to the domain that's being queried or to the name server name. But the probing information that we have is bound to IP addresses. So there's kind of an interesting slight impedance mismatch here between basically as we're doing the probing, we're collecting this information and remembering it about different authoritative IP addresses that we connect to. And those are so that it doesn't quite match up with where we expect the signals to land. Because I think while we have talked in this working group about signaling being attached to the reverse lookup, that is the in-adder zone, I don't think anyone seriously thinks that that's a feasible approach. So there's a weird impedance mismatch we have to think about there. And then the other question is, like, if I get a signal, should that signal also update the probe information that I've got, and if so, how? So I'm raising these questions because I don't have any answers for them, but I think thinking about it with this unilateral way encourages us to sort of work through those problems. I see Brian and Eric in the queue. I'm happy to take queue questions. I realize there's been some stuff going on in the chat that I have not had a chance to read while presenting. Brian, you want to talk? I saw briefly that Brian turned on his audio, and then I didn't hear anything.
I didn't quite pick up. I said, go ahead, or I'll get out of the queue. I'm happy to wait to the end. I think the rest of your presentation maybe have information that I will be commenting on.
Okay, so I see a queue is lining up. This presentation and this paper, I think Joey and I both intended this as a provocation. So the fact that we have 5 people in the queue suggests we may have succeeded.
Yes. So Daniel, why don't you just go ahead and finish your presentation, then we'll start working on the queue.
Yep, sounds good. Okay, next slide, please. So if we get a signal again, so one thing that we noted as we were sort of sketching out what this unilateral probing would look like was that the probe doesn't need to send SNI because it's not going to care what the authentication looks like. It's going to do a connection, and if the TLS handshake or the quick handshake ends up working, fine, we're good. We've protected against passive attackers anyway. But a signal connection might send SNI, and that itself might be a privacy leak. So there's some interesting interactions there. And then we have this final sort of thought experiment is there some situation where a signal connection would succeed where a probe fails? The only thing I could think of when I was trying to like work through the problem space was a situation where the signal connection does send an SNI, and somehow that allows the server to offer a connection, the authenticated server, authoritative server to offer a connection that it wouldn't do if no SNI had come in, which is why we gave the guidance that authoritative servers should ignore SNI when they're offering these things. That is, if SNI comes in, if you get a probe with no SNI, don't abort just because you can't figure out what the name is. Just serve any old certificate or identification. But maybe there's some other situation where a signal connection could succeed where a probe is failing. Next slide. So I'm not going to get into the details about what the other drafts are. Obviously, this touches on a bunch of them. There's more that haven't even been mentioned here. We're hoping that this stays out of the way of the drafts that actually do specify protocol elements. We're just saying, what can you do if you didn't want to do any active mechanisms? But if folks who have been thinking hard about these other drafts want to weigh in on how to improve this unilateral step, that would also be great. So next slide. I think that's it. Right, so there's the GitLab link. It's in my personal GitLab account. We will publish it to the data tracker shortly. I think we have provoked a queue of 7, so let's get to it. I recognize that Ben is at the tail of the queue, even though he was the first one in the queue earlier.
Well, let's just work from the top, Daniel.
Okay.
Yeah. So Brian Dixon.
It's definitely interesting. I think it'll probably be the case that aligning it with any of the authenticated signaling mechanisms probably be advisable, modulo response from the working group to those proposals. But the other comment I have, and this comment is actually applicable to both the probing and to the unauth, as well as any other related proposals, is at least on my proposals, it's what's being proposed is the how, but what is left unanswered is the when. Right now, it seems to be the case that, especially both the probing and the unauth case, it seems to be an all or nothing. And I don't think authority server operators are going to be happy with that, or are going to be likely to enable encrypted connections if all the traffic is going to go over that all of a sudden. I would be interested in soliciting suggestions from the working group on ways that a client could signal to a resolver that it wants privacy on the upstream queries from the resolver to the authoritative, so that it can reduce to the absolute minimum the traffic that is encrypted, so as to not overly consume resources. I.e., if you can minimize the resource consumption, you can get the thing that you want, which is encrypted transport for sensitive queries, but you avoid consuming resources on all the queries that aren't sensitive. Whether something's sensitive, a signal, I understand, but that's sorry. Go ahead.
No, I think that's a really interesting point. I think you and I might disagree about what the goals are here. Ultimately, my goal here is to get as many of the precursor to authoritatives traffic that's flowing across the network to be encrypted. So I am not contemplating at least this draft explicitly does not contemplate the idea of marking specific queries as sensitive. It is strictly about getting as many queries to be encrypted as possible. And I want to just point out that I think this draft actually does provide the kind of signaling you describe. The signal that I send to an authoritative that says I want privacy on this query is I open a connection to port 853. Or maybe I open two connections to port 853, one on TCP and one on UDP. And if the authoritative server decides I am out of resources, and note that this draft actually explicitly contemplates the resource overload situation, it says stop answering. If you as an authoritative server can't afford to answer encrypted queries, then stop answering on port 853. Just send back port closed. That's the cheapest thing you can possibly do. And so while I agree with you that we want the clients to do something explicit so that the server knows they want encrypted connections, I'm pretty sure that just making the connection seems sufficient for that. Now, if you think that we can't have the motivation for this draft is a world where all recursive to authoritative traffic is encrypted. If you think that is not possible, if you think that authoritative servers will rebel and refuse to offer it, then we have a whole different set of thinking to do, I think, as a working group. But the goal here, in my opinion, is to have all of the recursor to authoritative traffic encrypted.
Okay, so I realize, IETF, we're participating as individuals, but my day job is with GoDaddy, and we run authoritatives for the bulk of the long tail of domains. And I can say for absolute certain, there is no way we could accommodate with our current infrastructure or even our proposed expansion of infrastructure, all queries coming over TLS connections or even over TCP connections. It has to be
what about
a very
over quick
small
connections?
Same deal. The state that's required and the overhead, even with establishing connections, I'm pretty sure we will do experiments for sure. But and I don't think the signaling would be between the recursive and the authoritative. I think the signaling would be from the client to the recursive, and the recursive choosing whether to use an existing open connection for the query over DOT or DOQ versus sending it over UDP or TCP. There are other mechanisms for associating domains with encrypted or not using the name server names, because a name server can have multiple names at the same IP. But this is getting a long way down the discussion, but I think that needs to start. The conversation needs to start in terms of, is there a way to do this and how? Okay, I should get into the queue now.
Okay, thank you, Brian. I think this is a really interesting thing to raise, right? I mean, I don't think I've heard this in any Prive meetings before, that authoritative simply would be unwilling to accept encrypted connections, like unwilling to turn on encryption. I mean, maybe the answer here is that's true for some authoritatives, and those authoritative will just have to send port closed responses on port 853 until they get their infrastructure spun up. And that's one way that you can differentiate between authoritative hosting providers or not. Eric, you're next in the queue.
I just wanted to add, because we and Eric that maybe we'll keep something on what. Sorry?
Can you be louder?
Okay, sure. Is this better?
Perfect, thank you.
All right, thanks. Yeah, that maybe what we could add is simply in the authoritative servers recommendations part, it could be some sort of sentence explicitly mentioning what you say, DKG, that if an authoritative server is faced with resource exhaustion or something, then the cheapest way to signal that would be simply by closing the ports. I say this in order to keep consideration to what Brian said, and also with the understanding that that should not hinder in any way the development of these use cases and these scenarios, in my opinion, if that makes sense.
Yeah, we actually do have a section called resource exhaustion in the draft that's under the authoritative server guidance, and it basically says, hey, if you have insufficient resources, I think the sentence is, an authoritative server facing resource exhaustion should cleanly close open connections from recursive resolvers based on the authoritative's preferred prioritization. And then it offers a prioritization scheme for how to close existing open connections, and suggests that maybe you just want to, I think it does not currently say stop answering on encrypted connections. We should probably add that. You're right. Next in the queue.
Oh, it's me. So thanks for presenting this. This is rather more carefully worked out than perhaps necessary. So thank you. I originally wanted to talk about the sort of like the issue of SNI and like labels and whatever and scoping for the HSCS tag mechanism, but I think like Brian's comments, I think like forced us to step back, right? I had heard what you sort of said, DKG, that like, I hadn't heard anybody say like, oh, we just don't want to do this at all. I'd heard that before. I think perhaps that is where we're looking at stuff, which is like all the work that you and I and Ben and Paul and Peter have been doing has like been premised on the idea that we're trying to get like more or less universal, like encryption, TLS from the recursive authoritative, right? And if the story really is that like the people who run the authoritatives are uninterested in like delivering TLS, then like we can just like all pack it up and go home, and like that will save like an enormous amount of effort, like on all of our parts. And I don't think that like trying to like say like which like I don't think like if the prize at the end of this is like that the clients get to label like 1% of their queries as sensitive, and like those get encrypted, like that just is not like that's not just isn't worth the squeeze. So so I think like now I must say I'm like quite surprised to hear that people think the load is excessive. Like I mean, compared to like the load that like that like a modern CDN takes, this is just like not like a trivial important amount of data, which is why like all these people are offering free, why all these people are offering free TLS like those services. But like if the people are unable or unwilling to do so, then like that's the place to start, not to sort of spend like endless hours trying to define like a new way to like do something nobody wants to do. So I think that I would definitely encourage like the working group placements on that topic, which I think circles back to this point I was making earlier about my draft and Paul's draft, which is like, like we should like I think we have like a broad understanding of like what the solution space looks like, and we ought to figure out what piece of the solution space people like are actually willing, deployers are actually willing to do, and like only focus on the pieces that are relevant. So I guess I would definitely see some people queuing up, which is great. I would love to hear like people who operate authoritative servers, say, we would or not be willing to do like we would be interested in something which like leads us to like universal encryption from like authoritative recursive authoritative. And I'll take my comments with SNI like separately to like to the list or GitHub or something if they become relevant.
I am definitely interested in your comments on SNI, Ecker, but yeah, I hear you. I want to also note that this draft actually doesn't. There's nothing stopping anybody from just implementing what's in this draft. The whole point of this is that it's not about any sort of handshake or like, if you run a recursive resolver, you can just start doing this. Likewise, if you run an authoritative.
I just selfishly want your intellectual effort on something else. It's not if no one's going to do this. I do want to say one more thing, actually, which is, Brian suggested that like, that servers, that like the clients should like somehow say no, like I want this or not. We don't need a mechanism for servers to gradually roll out support for this under the in the design you propose. Like they can simply stochastically send port closed to like some fraction of the IP addresses, and that is like the cheapest way for this to be done. Trying to like build some sort of gradual internet-wide gradual wallet mechanism, not a good plan. Just select an IP address range and return OK versus port closed.
Peter?
Hello there. A couple of comments. I like this draft, but Paul already mentioned that. One of the slides said TLS reports. There is a draft from Roy Arendts for doing DNS error reporting, which might be of interest, although I can see the trouble with doing DNS error reporting in DNS.
Right.
DKG, can you go to slide 5, please?
I don't control the slides, but I'm happy to see it go to 5.
Oh, there we go. This says the draft maps out the internal state. I found that the internal state it starts from is severely different from the internal state in our resolver. And also in general, I feel the draft is too prescriptive in this area, but that's all fixable in editing.
I would love edits.
Yeah. But I guess we'll have a few other conversations before we get to fixing that. Like, do we even want encryption everywhere, as discussed before in the queue? On the SNI node, I believe that the content served by a name server should never depend on the SNI. But indeed, SNI might make sense in some authenticated scenario.
Yep.
And finally, several people said this today, several people have said this in the past. If a name server does not want to serve some encrypted transports, it should just return TCP resets. When I proposed this earlier, Brian Dixon told me that would be too expensive. But I don't know what to make of that. That's all I had.
Thank you. Eric Nygren,
Sure.
I think you're next. Maybe Eric and Peter can drop themselves from the queue so we can actually see the queue get shorter.
Yeah. So as a operator of a large authoritative DNS platform, I think one of our, or probably our top priority is availability and stability. So I think this goes to what Brian said earlier of being able to control what's going on with clients is critical, and change safety is one of those things because of availability that is also critical. So being able to roll out changes safely and understand what behavior they have is very important. And I think what this comes down to is that we really need to be careful in this space if we do want to get to the kind of having as much of this encrypted as possible in the long run, is not poisoning the well in the short term. And I haven't read this draft yet, but I think the idea of laying out some ground rules of if you're going to do it, probing, here's how you might do it, would actually be helpful there, especially if we talk about how not to do it. Because one of the things, just as a concrete example, most large-scale operators have behind a single IP address, we'll have a pool of tens to hundreds to thousands of servers beyond that single IP, and are going to roll out changes very, very slowly, incrementally. So only one or two servers in that pool might start off having a dot or a doc. So we'll want to think about how do we communicate that, and how does that interfere with kind of a scheme like this. Like if for example, introducing ADOCs onto kind of one backend caused a bunch of clients to now start having timeouts because they discovered in the probe, but then got occasionally mapped to a different backend, and then started having timeouts. That would prevent actually being able to roll out to the whole cluster, because we'd start seeing, hey, there are timeouts here, and then there'd be no way to actually do the rollout. So kind of if we just need to make sure that any probing mechanism we deploy, or we let people, or that people are encouraged to deploy, doesn't mean it says that we don't have a way to deploy a fully authenticated mechanism longer term.
Thanks, Eric. I think that's a really good point, and that's the goal of this proposal, is to try to flesh out what we think would achieve the results that you're describing. I don't know how often the remapping that you're describing happens. It probably depends on the particular infrastructure provider. But I agree with you. Maybe the answer is we want to fiddle with the default timeout parameter that's described in the draft. The draft does, Joey and I tried to think about how do we make sure that we're not really overburdening providers that don't want to roll something like this out. And maybe we need more guidance on the authoritative side to say, hey, if you're going to try to do phased rollout, do your phased rollout on the basis of like partitioning the IP address client space. And we need to tell the recursors, don't share this state across multiple recursors that are querying from different IP addresses or something like that. Anyway, I appreciate your insight on that, and I would love suggested text or proposals that would make this probing guidelines something that would encourage and facilitate deployment. Thank you.
Jim, you're up next.
I'm not hearing Jim. Jim?
I am not hearing Jim either.
Maybe we'll skip Jim for now. Stay in the queue, Jim. When you get your audio issues sorted out, we'll take Ben next.
Hi.
Hi, Ben.
Okay. Quick notes. I am aware of real offsite interest in 100% encryption, not like name conditional. I know auth implementers who believe that this is totally deployable and want to deploy it. So please make it possible. I don't think the impedance mismatch you mentioned is a real problem. I just kind of think that you'll check if you can do the if you have the full authentication support, and if that works, you won't even get to the stage of checking if you have some cached hint for opportunistic. As was mentioned before, DNS error reporting is, I think, actually a perfect fit for telling authoritatives whether TLS is working. We just need to make sure it fits, but I believe it does. I don't think we need an STS signal, as you mentioned. I think the existence of unilateral probing here makes that STS signal unnecessary. Instead, we should just say that if you create an explicit signal, if you publish an explicit signal declaring that you support ADOT, then you have to actually support ADOT.
So Ben, hang on a second. Can I just respond to that one point? I don't want you to make a bunch of good points and then I've forgotten which ones to respond to. For that one in particular, the one non-strict signal that I could imagine saying is that I do want error reports, right? Like I could imagine if I've got an authoritative and I haven't deployed ADOT, I don't want to get my DNS error reporting stuff flooded with information about how, hey, my authoritative encrypted transport isn't working.
Okay, that's a really interesting point. We'll have to figure out how to say what you want error reports about. And last, I'll just say I'd like to be very clear that resolvers using this must omit the SNI. Thanks.
Jim Reed back again.
Brian? Oh, Jim. Was that Jim? You're sending audio, but we're not hearing you. Brian Dixon, want to go while Jim still sorts out his audio?
Yeah, I just want to make clear that we definitely want to provide the ability to do encrypted transport. So my suggestion that it not be 100% is not that we don't want it to be 100%. I don't think we'll be have the facilities to do that. And the problem with all or nothing, if that ends up consuming resources and it ends up being nothing, I think that's not to the benefit of the efforts here or to the group. If it's a resource consumption thing, not being greedy, not having resolvers that are greedy and consuming all the resources is an important part. To make the analogy between UDP and TCP, UDP allows you to be greedy. TCP has back pressure through, the retry and things like that let the available resources align with the demand for those resources. But since DNS is effectively stateless, whether it's over UDP or whatever, each query and answer consumes whatever amount of resources it takes. That's why I'm suggesting having some method of effectively providing self-control on the resolvers would be to the advantage of all the resolvers rather than just a few. Keep in mind, there are about 3 million IP addresses that are seen by authoritative servers that are resolvers, legitimate resolvers. So the balance of resource consumption, if it's not possible for the resolvers themselves to self-control what amount of traffic they're sending, they're going to have the effect of the people who actually need privacy from recursive to authoritative. If it's not available because the resources have been consumed, that's really that, from my perspective, as just a working group participant, that doesn't seem to align with the intent. And certainly, I remember earlier, it may have been in this group or may have just been in conversations in the hallway, the intent of definitely client to resolver all, but it was not the case that resolver to auth all encrypted as being a strict requirement for what dprive is doing. And that, to me at least, seems to fly in the face of what previous expectations were. And I don't know, I don't have an answer, but I think that's something that needs to happen in terms of discussion. Thanks.
Thanks, Brian. I think I agree with you that it would be a shame if greedy clients caused the ecosystem to refuse to adopt. And that the goal of this draft actually is to describe mechanisms you can do as a client to reduce the amount of greediness, and also to sort of give authoritative server operators the guidance that they need to say, hey, yeah, it is okay to prioritize my clear text traffic while my resources are constrained. So if you have specific suggestions for how to ensure that these things are less greedy, that don't involve the stub saying to the recursor, hey, this is a sensitive query, I'm all for it. The reason I'm concerned about stub signaling to the recursor, like, hey, I need this query to be private, is I honestly cannot imagine end users making that decision in a way that makes sense. The trouble with these leaks is that they are privacy leaks. We don't know when something is going to turn out to be private. You might only learn later. Even if you could distinguish between things that queries that cause harm when they're leaked and queries that don't, you might only distinguish between that after the fact. You might never know that it was a problem. And I think introducing some new mechanism that asks DNS clients to bin their queries into sensitive queries that need encrypted transport between authoritative and recursive, and queries that don't, is just pretty implausible to me. And if the goal is a wide-scale deployment, then we need to think about how to do that wide-scale deployment without introducing that kind of signaling. So if you have suggestions for the draft that help make things be less greedy and make it less scary for deployers on either side, please contribute them. I really appreciate your insight there.
Sure. I would just offer two more comments along those lines. One is, it might be the case that it's not on a per query basis, but on a per client basis. So there might be some small percentage of your clients that have to have privacy. If those queries are coming over encrypted transport from the client to the resolver, the existence or non-existence of the request to have those queries be treated as sensitive would not be visible to an on-path observer or off-path observer, passive observer, because that traffic being encrypted allows for, whether it's a per client basis as opposed to per query basis, but something along those lines would be valuable. Sorry, I'm gonna add one more question, suggestion,
Sure.
Then I'll drop off. Yeah. The other thing is, I would see actually with the probing, I think you do want to do SNI strictly because of the potential for authority operators to use different names and offer encrypted transport only on a subset of the names for a particular IP. And that's what our plan would be. Thanks.
Thanks. So let me so this is interesting. We just had one person say, must not send SNI, and we just had somebody else say, should send SNI, or maybe even must send SNI. So that's something that we'll need to sort out. As far as your point about this being a per client rather than per query configuration, your description of that, and maybe this was not exactly what you meant to say, but your description was if a client must have their queries encrypted. I want to point out that this mechanism is a failure for any such requirement, because this mechanism does not defend against an active attacker. In fact, it doesn't even defend against a resource-exhausted authoritative server. There will be, this mechanism is designed to fall back to the clear text. So if you have if the recursor has a signal from the client that says my queries must be encrypted from recursive to authoritative leg, this mechanism is the wrong mechanism to do that for. Ralph, you're up. We heard you about as well as we heard Jim Reed. Can you try again?
Maybe not. So what I would say, DKG, is I think there's been a lot of good comments here. So I think what I'd like to do is if Ralph or Jim want to either chime in on chat or reach you via email to get their questions asked, that would probably be the best way to go forward. And then I'd just encourage you and Joey to get your draft posted to the data tracker so people can get access to it, and we have it for historical record for the meeting.
Yep, sounds good. We'll do. We'll make sure that happens. Thanks everyone for the discussion.
Absolutely agree. Thank you, everybody.
All right, so the next on the agenda is Ben to talk about the DS glue. And it is all yours.
Okay. I'm happy to run my own slides, but if you want to do it, that's fine. Next slide. So to be clear, the scope of this presentation is almost the opposite of DKG's. This is only about authenticated ADOT. And maybe I need to be a little bit clear about what authenticated means. It seems like we've had some different definitions. So here's what I mean. I mean basically downgrade resistant. I mean an active network adversary cannot ever gain access to the DNS query or the response. All they can do is force a denial of service. Authenticated dot, I have this abbreviation A2 dot. Authenticated ADOT is possible without any modification to the parents. We can actually do this today using components that already exist. We could just sort of walk away and declare victory almost. But it requires resolvers to be very, very patient. So first, the resolver has to do an NS revalidation before using a name server. So I get an NS record in glue. It says, this name server is the name server for this child zone. Now I have to go use that name server and ask for the NS record again and use DNSSEC to validate that that's actually correct. And then I can use that name server. And also, before I actually use the name server, I need to send an SVCB query, assuming in this model that we settle on using SVCB. I'll note that the SVCB for DNS draft is now adopted in ADD. So if the resolver sends an SVCB query for this name and again uses DNSSEC to validate it, then in principle, we can do authenticated ADOT. There's some interesting lingering questions about how you do certificate validation. But apart from that, we're very close. The problem is that this slows down resolution of all domains, not just domains that are participating in this experiment. A resolver that implements this policy slows down resolution of every domain that it tries to resolve. So for that reason, it seems like this is not likely to be deployed at scale. Although if you disagree, I'd be interested to hear. Okay, next slide. So we've had a lot of different proposals in this working group, and we've got a few more today about ADOT parent signals. So within the framework that I've just specified, an ADOT parent signal, anything in the parent telling you to use ADOT, is purely a performance optimization. It's a way to make ADOT faster. And that may be really important because resolvers are impatient. So if we can't make this pretty fast, it may be that we can't get it widely deployed. But it helps me a lot to think about these parent signals in this performance optimization context where there's a slow path that we know would work and we're just trying to find a shortcut. Next slide. This, I think, is the most important slide of this presentation. This is the slide that I really want to focus on. The thing that makes these parent signals hard is that there are a lot of questions that we need to answer to figure out the shape of the solution. And there are a lot of plausible answers to these questions. So I'm not going to walk through all of these on this slide. This is just to say this is a long list of possible questions. Next slide. And these are those questions, again, with the answers that I put in to produce the DS-GLUE result. So I would argue that if you pick these answers, then the DS-GLUE design kind of falls out. And if you propose a different design, it's probably because you have different answers for some of these questions. And maybe those are valid answers. Really, what I would like is for the working group to think through, or at least somehow come to consensus on these answers or on the answers to these questions, because that's going to shape the design that we come up with. So briefly, we cannot slow down the resolution of any existing domains at all. We do care about authenticated DNS over TLS under non-ADOT parents. An example of that is the dkg.gitlab.io link that was just sent around, right? So if .io is, as a TLD, is not doing ADOT, then we might still want authenticated ADOT for subdomains of gitlab.io so that we don't see that we're actually accessing dkg.gitlab.io. Otherwise, we leak the DKG label. Can we require that the parents are signed in this case? Yes. Can we add new RR types to the glue? So the assumption here is no. That's different from, for example, draft ADOCs, which proposed adding new RR types to the glue. Can we add new digest types to the DS record? Yes, this relies on new digest types. There's also an element here that is optimizing for the latency of domains that do enable ADOT, because hopefully, eventually, that will be a large fraction of the internet. And finally, can the child atomically update whole batches of glue that contain multiple RR sets, the NS and the DS and the glue all together atomically? This assumes we cannot rely on that. Okay, next slide. So the result of those assumptions, from my perspective, is the DS glue structure. So this is a new DS algorithm type called DS glue. It also relies on a digest type, which has previously been proposed, called verbatim, which is a fake digest type. So effectively, it lets you just plop arbitrary bytes into what would normally be the digest field. And so the DS-GLUE, each DS-GLUE record contains a TLV encoding, a compact encoding of an RR set, a glue RR set. This has to be an RR set below the zone cut inside this child zone. And so to prove that, only actually the prefix of the name is encoded. And so the child zone name is implicit. You can also encode non-existence of a glue RR set this way by encoding an empty RR set. Next slide. What does it mean? So if you get a DS glue record, it's a DS record. And so it's subject to the standard RR sigs over DS RR sets, and the whole resolution fails due to bogus if anything is tampered or removed. That's the real authentication value of all this. And how do you interpret the contents? So the contents of this dsglue record, the RR set inside the record, is a glue RR set. That means it's only for delegation following. It's not authoritative for the child zone. It cannot be returned to a stub resolver. It's only used during this delegation process. And it can repeat ordinary glue, in which case the DS glue takes precedence, RR set by RR set. In principle, you can represent any glue of any RR type this way, but the draft says basically don't do anything crazy, because like originally I had tried to put NSEC RR sets inside the DS glue, and it became clear that that was very confusing. So instead, we're just going to say you have to stick to some RR types that are understood, and we can expand that as we understand more. Next slide. So here's a very simple example. Here's a totally ordinary child and parent zone. They happen to be using DNSSEC and CDS, but they are a totally ordinary child and parent zone. Next slide. Here's the same example with, as I was talking about at the beginning, the slow A2 dot. So all you have to do is drop an SVCB record into the client, and in principle, a sufficiently patient resolver could revalidate the NS record, check for the presence of an SVCB record, find it, upgrade to DOT, and then actually issue the query that it wants to issue. But this is slow. So next slide. This is what that zone looks like, again, with DS glue. So what we've done is just added 2 CDS records. Each of those CDS records encodes an RR set. One of them encodes the NS RR set, the other one encodes the SVCB RR set. CDS copies these into the parent verbatim, and we're done. Notably, in principle, the parent doesn't need to know anything about this. As long as CDS is working, the parent just gets some more DS records, and that's the end of the story. But to a resolver looks in the parent zone, and if the resolver is DS glue aware, it sees that the DS record contains these authenticated glue RR sets, and it can use them to go directly to DNS over TLS. Notably, if the resolver isn't aware of DS glue, then these just look like DS records of some unknown algorithm type. They're ignored. Next slide. So my point here is DS glue shows that we can do authenticated ADOT even under some very challenging assumptions. We can do it with no slowdown for non-participating zones. We can do it with minimum latency for participating zones. We don't actually even need the child zone to be signed. But really, this is a very large design space. There are a lot of different possibilities here, and we are going to have to figure out where we want to be in that design space. That could take a while, but also we're not blocked. If we can agree on some of the details of the slow path, we can actually get started with that today and start experimenting. Maybe we can't deploy at scale, but we could at least set up experimental resolvers or very privacy conscious resolvers that are willing to make that performance for privacy trade-off. That's all for my slides.
Ben, Warren, looks like you're first in the queue.
Thank you. Yep, this is Warren. So I mean, I will happily say that I do like the fact that this is authenticated, but it does still feel to me quite complex. I do think it's something that's potentially a reasonable thing to work towards, but I still think that something like, opportunistic name hack for now is a good way to at least get some of this going in the meantime. My big concerns with this is it requires DNSSEC, which is not a huge issue, but there are a lot of instances where end users cannot really publish arbitrary DS records. There are a lot of things where people have web UIs in order to insert DS records, and they only allow a really small number of them. There's also places where the child provides the DS key to the parent, and the parent is the only one who generates the DS record. So I think as a long-term, this might be.
So for what it's
Sorry.
worth, this actually can be made to work with CDNS key, but only if the child can also convince the parent to use the verbatim digest type.
Yeah. And in the cases where it's actually the parent who generates the DS from the DNS key, that gets weird and tricky.
Right. The parent can generate the DS record, but only if the child can tell the parent to please use the verbatim digest type.
Yeah. So, I mean, again, I think as a long-term thing, this might be a reasonable thing, but I still think it's worth the getting something opportunistic for now, because then we at least have some protection. Yes, it's not perfect, but it sure is better than nothing. Anyway, soapbox right over.
Thanks, Warren. Jonathan, you're next.
Hey, everybody hear me? Yes.
Yeah.
Great. Okay. So I like where you're coming from with this. I like particularly the idea of setting out, this idea of these are the questions that I've answered in this way, and that's how I got here. I think that's great. One thing I kind of want to quibble with is this idea of whether or not we can ever add new RR types. We've seen, I think, many proposals here and in other groups of using DS for things that are not really DNSSEC. There's clearly a need for a better record type in the parent of some type, whether it's NS2 like Tim Maple's proposal, whether it's some general purpose thing, it doesn't matter. There's clearly a need for that. And we also now have a mechanism that's been relatively successful for a couple of years for breaking changes, which is Flag Day. So as part of this work, I'd like us, at a minimum, Prive, and ideally bringing it to DNSOP, to agree on whether or not we can ever add new RR types to a parent. And if we say no, great, let's say that out loud, and let's say you've got DS and that's it, have fun. If we don't believe that, let's say that as well. Because I think we're all making this assumption that we can't do it with that, but clearly clearly we've done it in the past. So let's either decide that we could never do it, or let's decide that we really need to do it. I don't like this middle ground of we'll just assume we can't do it, so we'll overload something that was not its original purpose. And that's not, a complaint. I like the way the draft works. I really just want us to tackle that question as part of this and agree as a group on the answer to it, if we can.
Thanks. I'll just say that there are shades of gray in there too, right? Like we've heard, I think, opinions in the working group that new RR types in the parent are possible, but the time scale for them is essentially too long for our patients for this work.
Sure, and that makes sense. And then maybe another aspect of it is, we decide that there's a time aspect to it. And, yes, you can have them if you're willing to wait N years or something, but I also think we can play with that time. So I'd like us just to all think about that as a group and where we can go going forward. Thank you.
Thanks.
Thanks, Jonathan. Eric, you're next.
Wasn't that Jonathan?
Eric?
It's me, actually, yeah. Thanks for the presentation, Ben. I appreciate your attempt to smuggle the entire DNS into the parent zone. That's solving this problem, so we'll never have to deal with it again. I think that the most important slide, or rather the most important slide with the answers, is a great contribution to how to think about this. I think I would just go back to sort of my appeal from my previous two appearances on the microphone, which is we have spent probably the past 2 years people trying out different different kinds of permutations of the design space in an attempt to find something that people will accept, right? And that we can get consensus on. And what I see is every single one of those has sort of for different people perhaps has that's clever, but we can't do it for this reason and we're not going to do it, right? And so I would implore the chairs to try to craft some mechanism for getting us out of this hole, even if that is declaring defeat and going home, because we are burning an enormous amount of intellectual effort by you and me and DKG on trying to solve this problem. And if the answer is it's just a hard no, if we go through that previous, I mean, if the answer is go through that slide, but if the answer is that none, basically those things all have no's on them, then let's just admit that and go home, because it's just not worth refining these proposals over and over again merely to discover they cannot be done. Though I think this is good work, and like I'd be more if this were the answer, I'd be more than pleased like for this to be the answer right away. So I don't mean to discourage you in any way. I just don't. I'm trying to think about respectful of your effort, right, and my effort and other people's effort.
Thank you.
Paul, you're next.
So when we used to have face-to-face meetings, sometimes somebody in line would get out of line and say, I don't need to say anything because the person in front of me just said everything. So I'm doing that now. Everything Ecker just said.
Thanks, Paul. DKG.
I also like this draft. I like this framing. Thank you, Ben. I have one question for you, which is, have you tried to publish such a record in any authoritative zone, or do you not want to talk about that on the mic?
I haven't attempted to do that. I mean, yes, the truth is that I think there are some barriers to doing this as is today specifically at the TLD layer. Below, for lower zone cuts, you can do whatever you want. But with TLDs, you need some way to push those DS records into the parent, which means you need CDS support. There are only a small number of TLDs that have their own CDS support, and a lot of those CDS implementations have filtering for defined algorithms. So it's common for parents to perform a little bit of basic format checking on the CDS record, including checking that it has a known algorithm type. So
okay, so look, this mechanism, we've been here before with TXT records versus, say, SPF records, right? This is the same game, just at the next layer up in the DNS hierarchy, right? Oh, we can't distribute SPF records because a bunch of DNS hosts refuse to publish them. And now we're saying that the parent zones refuse to publish certain things. So there's clearly a need for this to be published. Either the parent zones can decide to publish whatever these hypothetical new code points are within DS, or they can publish them as new record types. The parent zones that refuse to do that are basically directly blocking progress, and we just need to say, this is what we need you to do. If we think it's a bigger lift to ask them to accept new record types than to ask them for this, we should ask them for this. Ben's right, we're not blocked unless we just let ourselves get stuck between these two choices. I would be fine with this being a result.
Thanks. Yeah, I do think just adding new record types is a bit more complicated than it sounds, because if you just add new record types to the glue, they're not authenticated. So we also need to figure out what our plan would be for authenticating any new authenticated record type. That's never been done before.
Right, no, sorry, I meant to say we need new record types that would be signed record types by the parent zone. That's what I meant to say.
That's a novel concept.
Thank you, Ben.
Peter, you're next.
Yes, hope you can hear me. So I think the goal that was mentioned in the beginning of the presentation was that an active attacker can't learn anything about the query. And you said that you could also do that without the S-glue if you perform an S revalidation by asking the name server what the NS records are. And I think at that point, you're already leaking the child zone name to that name server that you're querying, which has not been authenticated. So I don't think the statement is true that nothing's learned by an active attacker. And if you want to avoid that, I think using the S-glue is one way to do it. And as far as I understood, the DS-glue would contain information from the child zones, such as the SCVB record, for example, SVCB record. But as I just said, it's not good enough to query that stuff from the child name server, because at that point it's not authenticated yet. You have to query from the parent anyways. So what's the point of keeping that record in the child zone? Why don't you just add it to the parent only in the DS-glue?
Sure. So you might be right about that first point. I'm going to have to think about that a little bit more. On the second point, I don't think it's true because the owner name of the SVCB record is the name server name, not the child zone name. So in this, the model that this is all in is that the name server name is not sensitive. It's the original queue name contents that are considered sensitive.
Okay, thank you. I confused that.
But so maybe that answers part of your question. In general, my attitude here has been that for conceptual simplicity, this stuff is glue. Glue is supposed to be replicating things that are actually in the child zone. So even if it's not necessary, it seems like a good idea to also have it in the child zone.
All right, thanks, Peter. Ralph, you're next.
Can people hear me?
Yes.
Okay, great. Different browser seems to have. So, I mean, what this draft and others are doing is pretty much changing the way how resolvers iterate or recurse through the domain tree. And basing this change on pretty much a hack by cleverly reusing some existing record, I don't think is good engineering. And I echo what John said. We certainly can change stuff at the parent. And the slide you had there with the here's what we can, what we can't do. Some people in the working group might have different opinions on what you can and what you can't do. So I think, and that's the basis that what maybe echoes that we seem to be impossible to come to consensus on this. So, but for recursing, I would rather see something that is more in line with how the DNS works. And of course, if you want to introduce that, you have to introduce records at the parent and the child, possibly also, to make that bulletproof rather than hacking it onto an existing record. That's just my opinion.
Thanks. Yeah, so I would be happy to see new drafts talking about what it would take to add a new authenticated record type at the parent zone. I do think that the barriers to that are remarkably high. You know, EPP being part of it, DNSSEC rules being part of it. You know, we're talking about, I think, a new set of our RSIGs from the parent and possibly new bits in the super parent, because we need an authenticated way to tell the resolver about whether these records are present so that an intermediary can't remove them and claim that a resolver is implementing the old behavior instead of the new behavior. Sorry, that an authoritative has the old behavior instead of the new behavior. So it seems quite tricky to me.
It
like a very involved change.
It definitely is hard, but I don't think it's impossible. And DNSSEC rules are also something. I mean, if we are going to this way, revisiting DNSSEC after so many years, we probably also can change stuff there. But it would be a proper kind of DNS solution rather than a hack that we seem to be budged on. That's what I just think.
Sure. I think that anybody who writes a hack tends to get a little bit attached to it. So, I have a view of this where, this is maybe just an expansion of the idea of what a DS record is. Maybe it's actually all of the signed data required for a delegation. But that's a matter of opinion.
Yeah, thanks.
Thanks, Ralph. And Robert, you're last in the queue.
Hey, thanks, Ben, for presenting. I just wanted to close on some thoughts on this versus the other drafts we've heard about today. I think we need to have multiple paths to getting a dot and authenticated a dot out there. If not today, like eventually the signals are going to change. Whatever we hear about today is going to, through experience, turn out to be wrong. And from my point of view, having coexistence and transition are key requirements. Some of the other comments we heard today about onboarding load or making safe changes to infrastructure, those all are very important. So, I think maybe we need to shift away from perfect towards accepting any draft that has promise, even if it's flawed full of flaws or like tons of flaws. If it works, we should perhaps accept it. And I guess what I'm saying is we should lower the bar from to could work instead of works universally or has unanimous support by the working group.
Yeah, I'll note that our charter discusses authenticated ADOT as something that we should pursue on an experimental basis. So it doesn't require us to come up with a standard or proposed standard level solution. An experimental level solution is also within charter, is clearly within charter. So, so it may be that there's work here that the working group wouldn't like as proposed standard, but that the working group would like as experimental.
Yeah, Ben, I'll just follow up with that one because the chairs put a note to the mailing list several months ago asking about interest in doing more of an experimental approach for some of these things. So if we can get a group of people interested in doing that, the chairs would definitely encourage that kind of experimentation.
I think that'd be great if the chairs could organize that. That would be fantastic.
Sure. All right. Thanks, Ben. All right. Next on the agenda is Brian Dixon to talk about actually 4 drafts that he just pushed links to the mailing list the other day.
Hi, everybody. So I guess the first comment up front is the drafts are the latest version of some things that have been working on for the last several weeks. So I apologize for the late push of the latest versions of those to the list, but in any case, they are what they are. The reason I'm presenting both drafts that are in Prive and DNSOP is that they're primarily motivated by the ADOT component, but some of the other drafts have wider applicability, or are better suited for being in DNSOP. So the only reason that they're in DNSOP is they're a better fit there, but that the primary draft depends on them in terms of like how it works. Next slide. So this is what I was taking as a takeaway, or how I was viewing what would be goals, at least in terms of my view on things, for DNS over TLS to authority with the authentication. And I think they're pretty straightforward. This is going to be kind of similar to what Ben's questions and answers were, but with different answers. So the primary goal is obviously channel security between resolver and authoritative server being available. Using TLS as the channel security mechanism, there's no real alternative there. And I'm including a relaxation on these TLS certificate types so that this is more easily deployable and has less of an overhead or encumbrance on anybody who wants to actually do this. The more flexible you are on TLS cert types, it avoids creating a economic penalty for having to do TLS. Obviously, another goal is maximize interoperability. That's just an obvious thing. And the next one, I think it acknowledges the current time frame for making any kind of changes in terms of record types and possibly even BS hash algorithms. I'm not sure that those will be deployable in a short time frame. What I'm taking as goals is making it deployable as quickly as possible, and including avoiding any use of non-DNS elements, and limiting new DNS protocol elements to those that are strictly required. So if there is some portion of the design that could be done with DNS protocol elements or could be done without them, I'm picking the do it without them in order to minimize the friction between where we are now and having something that's deployable or deployed. Signal ADOT support and permit secure discovery. That's for downgrade resistance and to avoid needing to probe. I see probing as something that itself could be abused or generally something that is not strictly needed or desirable. Absolutely validate server identity. That's what the authenticated piece is in terms of the goals. Protect against downgrade attacks, and resolver versus authoritative server roles. I'm looking at this from both sides of the equation. So there's what you do on the authoritative side and what the resolver does. So in these proposals, I'm saying I'm putting strict requirements on what the authoritative servers have to publish or how they do what they're doing, and what the resolvers do, those recommendations. They can be ignored, or there is a penalty to not doing some of the things, but these are not requirements. Next slide. So a consequence of those goals is what are some non-goals that I inferred from the goals. That encrypted transport does not provide data integrity. DNSSEC exists for that. So this is not something that is a goal for what I'm proposing, and I think it should not be a goal for any implementation or any proposal for any kind of ADOT. Does not require use of web PKI. The reason for this is this is all DNS. The resolver to authoritative, it's strictly DNS queries and DNS answers. I see web PKI requirement as being something that would be questionable. It may not be acceptable to all participants or all operators, and it's not necessary. So I'm seeing this as a non-goal. The next one does not require a single unique server identity. That's actually a goal, is to actually have multiple server identities, which allows for distinguishing the behavior, whether or not it supports ADOT for a particular server, as signaled by the name and attaching the behavior to the names of the name servers. A server and an IP address can have multiple names. This is actually a really good way to allow incremental deployment of ADOT associated with, for instance, zone names. It doesn't require registry side changes, and it doesn't require registrar side changes, with one minor change, which is that the name server validation component might require registrars to add support for new DNS key algorithms. And that's generally going to be a question of their validation on updates sent for DS records, whether it be through CDS or through UIs. Next slide. Next slide, please. So the other drafts that are included in this presentation are related or dependencies. One of them is the alternative to DSGlue, which I'm calling NSV, which is name server validation. It is proposing a new DNS key algorithm, but does not require a new DS algorithm. It encodes new data into the DNS key, which is actually never actually published, but the DNS key ephemeral data is then hashed and published in the DS record in the parent. And this is necessary to protect the domain name on the NS delegation. The name server name on the DNS, the validation from the delegation from the parent. So when the parent's doing a delegation, the NS record is not signed. You have to have some way of protecting that name of the name server in order to do any kind of lookup. This is where the authentication piece actually is tied to the parent. The next one is a new RR type, DNST, DNS transport signaling, that only gets published in the child. And the child zone here I'm referring to is the DNS server name, the zone that serves the DNS server name. This is necessary for explicit transport signaling and for the discovery by resolvers. And that's necessary, but that only applies on the child side. It's a new RR type. The glueless guidance, I think actually I can ignore this for now, so I'm not even going to talk about it. I think it ends up not being necessary. Next slide. Next slide, please. So this is the piece before you start doing TLS. You need to follow the delegation and have some way of finding the right name server to talk to do your TLS. If you need to find the right IP address, and that's based on the name in the NS record in the parent, the delegation side, and that's unsigned in the parent because that's how DNSSEC was defined. It's an unfortunate thing. So if you got an NS record in the parent, you got the domain name that's being delegated, NS, and then the name server name. The NS record is non-authoritative, can't be signed. The target name can be glued or unglued. The resolver contacts the name server by IP address only, and the DNS protocol on the wire actually does not involve the name server's name, only its IP address. And glue for the IP address, not authoritative, but that's irrelevant if you are going to revalidate that delegation as part of the overall authentication process. Next slide, please. Again, I'm just skipping over some of the stuff that I put in the original draft, but I think they're no longer needed. So boldface things here, just highlighting what this TLS A. Which is basically just TLSA records. So TLS means the IP address plus the domain name. Resolver connects to the IP address. The resolver has to revalidate the name. And if you've protected the NS name, with the NSV, you can now talk to the IP address and look for signed data within the child related to TLSA records, the name server transport, DNST, as a signaling mechanism, and you can also reconfirm the address record for the name server. But the main pieces are having this TLSA record to get the validation component for the TLS session, and that is within the name server's names zone, and that requires that be a signed zone because TLSA requires DNSSEC. And as long as TLSA validates, then you can trust the actual TLS certificate that you receive if it matches. So you don't need WebPKI, but you can use WebPKI certs. You just need that those have a TLSA record published for them. And the DNS messages are sent over the connection only after TLS is established. That's a very dense slide. I'm apologizing for that in advance. Next slide, please. NSV is name server validation. You're basically putting a hash of the name server name in a DS record and hashing it in a DS key record and then hashing it to the DS. And that allows the resolver to take the delegation NS records, the target names, and use that as the input to reconstructing the DNS key and then hashing it, comparing that against the DS record that is seen. And if it matches, you can now use that delegation, the NS name. And if it doesn't, you don't. It's just, how do you validate an NS record or the R data in an NS record? And this is strictly for protecting the target name in the NS. The other element about this is if, because of the way that DNSSEC is architected, unknown algorithms for DNS keys are ignored by resolvers. So it's backward compatible. That, I think, is a very key element of this. It's not going to affect any unaware resolvers. NSV aware resolvers are going to be able to validate the NS records and then continue on with the rest of the validation process. Next slide, please.
So just as a note, Brian, we got less than 5 minutes.
Oh, I'm sorry. Okay. DNST, it's just signaling, uses flags. It's as simple as possible. Only the necessary elements are involved. Next slide. It's designed to be downgrade resistant. That's mostly because everything's in the child zone of the name server name, other than that NSV. This means it's signed, and the signaling and TLSA records give you the ability to confirm the TLS certificates, and it lets you establish a downgrade resistant TLS session. Next slide. Next slide. Next slide again, sorry. And then there's some other stuff that's not really relevant. Interoperability, what they have to do and what they don't need to do. So it requires DANE, TLSA, clients, I guess I should say should instead of must, but validate. The mechanism for validation is DANE. It's optional for if the clients want to do web PKI, and they can ignore DNSSEC validation if they want, but that's not advisable. Next slide, please. And it's a work in progress. So not really been out there very long. I'm looking for feedback. I think it covers the absolute bare minimum required to get to something that can be deployed quickly. That's it for me. Oh, did I run out of time? I'm sorry.
That's right. We had a couple of different discussion points that kind of ran a little bit long. So
yeah.
But I also want to make sure everybody realizes that Brian, you're going to be talking about these slides again in DNS Stop in a few hours.
Yeah.
So
yes,
there is an opportunity there for on mic discussion. So thank you for that. Okay, so really quick, Tim.
Oh, I was just going to talk over the action items unless you want to. Go ahead.
Yep. No, go for it.
Oh, okay. The ones I put in the minutes, and people, if they want us to have more action items, just you can add them to the Etherpad. Action item on taking to the mailing list on moving DNS over DTLS to historic, and then update the port name. And of course, how we describe the name can, believe that as something for us. Also, we will talk with the AD about use case discussions from the unauthoritative draft. That's a pretty good comment. And I believe the last one is we're going to follow up on Ecker's mechanism crafting comment, and we will take any and all sort of suggestions on that one. But I believe those are the 3 action items we're currently sitting on. So if anyone wants to add more, please do so.
Thank you, Tim. So with that, if you have additional items that you think need to be noted, you put them in the minutes, in the notes, or send them to the chairs, and we will make sure that they get recorded. Otherwise, I will take this opportunity to thank everybody for participating. I actually was very grateful to see some of the robust discussions that we had around some of these documents, and hopefully we can come up with some approaches to help get some of this stuff unstuck and get more people engaged in looking at these proposals and either doing experiments or pointing out where they may be implementation or deployment issues. So thanks once again for attending the Prive meeting for IETF 112, and we look forward to seeing you next time at IETF 113. Have a good day, everybody. Bye.